Afternoon. Yeah, I'm John Berry, Innovation Engineer at Western Power Distribution, and it's sort of fallen to me to discuss around some of our innovative assets and the integration of those onto the network and the role of the SAPs. And I'll start by saying I'm not and never have been an SAP, so that will probably become clear as we discuss and how I end up producing the documents of how we operate and control those. Without actually being an SAP. So yeah, a little bit about myself and sort of why I'm stood here is I work in our Future Networks team, manage a portfolio of projects that principally look at some of our larger technologies integrating into the 11 or 33 kV network, and some of that experience hope to share and how we've come to a sort of a common methodology and approach to getting new technologies connected to the network. And most importantly, I'd be interested to hear what some of you guys, the approach you take and perhaps how we can all improve. A brief agenda. Thought it'd be worth having a quick point at what technologies I'm principally talking about, so what we've included into the network, so some photographs if anyone's not familiar. Little background in how we sort of used to manage them on the earlier stages of the projects and the lifetime. What we thought were some deficiencies around that and how we changed our approach to get a bit more commonality and perhaps how the rest of the business operates with bearing in mind these are new technologies. The benefits that we're hoping to or have already seen from that, and a little bit about what we've learned and what we've changed on specific technologies. So a little bit more technology focused this afternoon. So yeah, just quickly pointing at things. So some of the things we're talking about is a 33 kV STATCOM installed in the East Midlands, pre-saturated core fault current limiter, and if anyone wants sort of the specific details of what these things are or how they work, principally a fault current limiter, as it suggests, limits fault current so we can make more generation connections available to the network that contribute fault level. STATCOM's the same, giving us some voltage capability without having to do lots of asset replacement or asset reinforcement to connect new technologies, LCTs, etc. Another type of fault current limiter, and this is pretty interesting because it's running at nearly minus 200 degrees Celsius in each of those three cryogenic modules, and obviously that's a bit of a departure for an electricity distribution network operator to suddenly have things that are nearly minus 200 degrees C operating, and how do we make sure that's safe at all times. And the last one is also interesting because it's called a fault level monitor. What it principally does is create a fault between two phases of our live 11 kV network through an impedance, so we can understand what our source impedance is and then generate real-time fault level values, again, to improve our knowledge and status of the network to hopefully make our existing assets last longer. But just a bit of a flavour for some of the technologies that we've used and how they're a departure from what have been traditional assets that we've employed on the network, and how we make sure those are connected and operated, maintained safely to the network. So earlier installations, so some FCLs and the STATCOMs, what we did was we identified that these were sort of isolated instances of installation. These were principally funded through Low Carbon Networks Fund projects, or NIA, or latterly NIC as well. And we identified that these were a one-off installation as part of a project trial. And we originally said that these were going to be in one location. The best way for these to work is have a specialist or a certain small handful of specialists in the area that operating under our normal safety rules and procedures that had the local knowledge of how these devices were going to be operated and maintained on the network. So we were happy that that's a safe and reliable methodology for operating these, making sure they're connected appropriately. And I've mentioned that the pros on the system for this were it was well controlled, skilled operation of the new technology. We limited the access, we limited the availability to come in contact and operate these devices. The cons were we found that new technologies often have sort of, well, what I've described as teething troubles, issues with reliability and availability, staying connected to the network. And what we found was that was due to resource limitations, there was long periods of non-availability of the assets, and that was principally about getting the right person in the right place to do the right piece of work so we could make sure it was connected back onto the system and continue our trials as our innovation-funded project. And the challenge came then for us to say, well, what should we be doing by having these as isolated installations? Well, what could we do differently? That obviously isn't the case when we have thousands of pieces of switchgear transformers on the network. We don't have certain specialists who just deal with certain elements in widespread. So if we were forecasting that these technologies, as how we've sold these projects to Ofgem essentially to fund, how are we going to make sure that we were in place to transition through to business as usual while making sure it was safe for a wider range of people to operate the system? So we updated our approach and we really thought about how do we make sure we increase our safety. So obviously if a problem happens at 3 a.m, it's perhaps difficult to get the 1 or 2 trained people out to site. So how are we going to make sure that was overcome properly? How are we going to make sure that we could transition these to business as usual as quickly as possible? So we were really interested in making sure these new assets could move from an innovation trial, and if they were of value and we could make sure that we'd done enough to convince ourselves that they were of value, how we were going to take them to the next stage. And the big issue, I think it's probably shared by all the network operators, is how do we increase the availability and reliability of a new innovative device connected to the network? So we had lots of thought processes, and we went forwards and looked to understand how we were going to move them from a piece of new technology to what do we do for a traditional asset. So if we had a new style of circuit breaker, we'd update our wide range of policies and methodologies. So as part of this, what we looked to do was create sort of a standard innovation suite of policy documents to understand how these assets were going to be implemented into the network. And this culminated in 4 elements that has a close overlap to our traditional assets on the network. So engineering specification, what we did was make sure that we documented the functional and fundamental specification and requirements of a piece of technology. So this was essentially a document that we could procure another one if the decision was made that's what we'd look to do. It talked about all the smarter elements. So if we're talking about a cryogenic fault current limiter that has to run at -200 degrees, the safety processes and procedures that we have to go through to have pressurized vessels installed on our site, through to absolutely what you didn't want to happen on site. So the danger is always, and the risk is always, that we try and innovate everything. So we have different cable terminations, we use different VTs, we use different CTs, we use different specs for multi-cores and things like that. And that's what we'd found on earlier trials, that we got a whole new box and there was one bit of innovation in the middle, but the rest of it had been innovated as well because it was a great opportunity to try everything. The engineering specification really details, so let's keep the new bit smart, but let's keep everything else, the interfaces to the device principally, so cable types, terminations, things like that, were explicit that they overlapped with switchgear, transformer, other policies and other engineering specifications that we had in the system. A new one that we don't traditionally have, because we have a longer range of policies for system design and how we design and implement our network, was an application and connection guide. So we appreciated that these new technologies, how were we going to make sure that people could operate them safely, reliably and consistently? Well, what we wanted to do was make sure that when people turned up to site, they could pretty much expect to see the same thing, whether it was one here or 100 miles away. If it was going to be an SAP turning up or an authorized person, that they could relatively see the same thing. So what we developed was an application and connection guide, and that drove a methodology of how these devices should be connected to the network, what equipment should be around. And it's probably worth noting that sort of through innovation projects, we're keen to make sure we can switch these off quickly, safely, and without impacting customer connections, or customer supplies rather. So making sure that the same types of switchgear are in place, the same protection systems, so it's understandable, and that really drives through to the inspection and maintenance and operation and control. And obviously that's something that we have for all our pieces of kit, but as I mentioned, when we had small specialized teams that were focused on a specific piece of new innovative equipment, what really happened was we had large inspection and maintenance and operation and control manuals and procedures that were created by the manufacturer of these devices, and we use those larger documents and interpret them on a specific need basis and did our dynamic risk assessments and method statements based on those. And really what we wanted to say is, you know, that's not how we're going to transition to business as usual. That's not how we're going to make things as safe as possible, and sort of bringing it back to this morning. How do we make sure that that different people are doing the same thing where needed? So documenting fully robust inspection and maintenance documents, and that falls under sort of my control as the technical lead on these projects, and then operations and control. So we make sure that no matter where it is on site, that people are switching off the right bits, isolating, earthing, either engaging or disengaging the right level of protection before and after they've worked on it. And it also facilitated wider control in terms of the remote control room functionality. So control engineers could take a more practical and pragmatic approach to how they were going to operate for alarms and trips that happened sort of principally outside main working hours. So this is what we decided, and the challenge from the policy manager was to say that we'll get these documents in place before we energize the device. We don't want to be looking to energize the device before these are readily available to the engineers, the designers on site, because that'd essentially defeat the purpose. So what we look to say is at the top of this, and I guess this sort of aligns to the flows that we saw this morning, but at a more project level, looking in terms of the documentation. So I've already said that I've never been an SAP, and I'm not now. So, but it falls to me to pull these inspection and maintenance engineering specifications, ops and control documents together. So what we really did was said we need a functional approach to this, so how we're going to design the technology in the first place, and I've spoken about engineering out some of the innovation that perhaps crept in earlier innovation projects, and say let's focus on the core smart bit and keep everything else what everybody's used to. And we made it a principle to go through that process, make sure we witnessed and got the availability to go to the factory, do testing, witness that testing to get some familiarity, and that's been a hugely valuable thing for us to make sure we actually see the device before it turns up and know what we can expect. And what we also did was look to document that and share that with the guys who are the SAPs, both locally in the area and other SAPs who aren't going to actually interact with it immediately, but to get an understanding of what, and I think going back to this morning, what is the sort of common language and the nomenclature for different elements of the work that's required on the system to make sure it covers as many things as possible, and obviously getting our policy and procedure through. We then took a point to say what we want to do is make sure people are trained, so when they see it coming in the first instance, when they look to energize, it's not the first time they've had to interact with it. And that comes from our ops and control documents and inspection and maintenance, looking at doing toolbox talk. So who's going to be working on it? Who could theoretically be called out at 3 a.m. so we can actually get a resolution rather than isolating it and having it dead for 3 weeks while the right person comes off that job and looks to get it on the network. So that's been a huge benefit to us, and hopefully what we get from that is sort of optimize safety, operation and utilization of that asset, and also the system, and look to how we can actually show the benefits of that technology in the immediacy rather than looking from afar in its sort of open loop to closed loop process, we call it. So what could it have done, but what can it actually do? And that's been a huge part. And then taking some honest feedback of operational experience. So I think it's fair that even when we're designing traditional assets and traditional infrastructure work, we don't get it perfect 100% of the time, and that's certainly the case and exacerbated with innovation because of the levels of unknown that are associated with it. So getting some honest feedback of what is sort of good, bad, and what needs to be changed. So that's been a huge part, and saying, is that something that we can live with and there's a sensible approach to how we manage that, or is it an in-trial change that we fundamentally need to update, maybe even disconnect that device, go through that whole process again to sort of circulate and come back through to an ongoing cycle that we have for all our other policy documents. And I guess this all sort of sounds like common sense, but what we'd done initially was treat innovation as complete isolation, and perhaps other DNOs and other network operators can sort of share their experience of of doing that as well. And what we found, so just off-put myself by noting as a mistake of will instead of with there. What we really look to do is say, well, we're sort of thinking of innovation sitting here and trying to exclude other key elements of it and moving towards the business as usual. And I think what we've hoped and what we've found is the level of safety has gone with it. So moving from having one SAP with all the knowledge, so they were the only people allowed to work, operate, and control that system. You know, what happens when we lose that level of knowledge for whatever reason, or we have significant issues with the device. It takes up a lot of one person's time, which obviously isn't an ideal world. And then we have several SAPs with that knowledge, and the issue then is if we're working on big documents that have come from manufacturers that perhaps don't understand how we operate our specific networks, and that document would be the same whether it was an R network, UKPN, or somewhere in Germany, France, wherever. How do we need that interpreted? So we looked and said documents to manage the specific device, and then finally we think we're getting somewhere to understanding that in terms of documents supported by the appropriate training that goes behind it, and making sure that all that's happened and we can get the device suitably connected and operated onto the system. So I think I just wanted to spend a couple of minutes of sort of what have been the outputs of us changing our approach from this isolated methodology to a more integrated and wholesome methodology. So what we've learned as part of it, so the fault level monitors, as I mentioned, that's looking to put a minor disturbance on our network. So what we said was we don't want anybody being able to lean on that, come in contact with that, and so to get anywhere near it, they had an individual circuit breaker that needed to be isolated and earthed to allow us to access to view it, inspect it, or maintain or do anything else on it. And we really took that decision because we feel it was a genuine first of its kind onto the network. But what we've learned is that we've got experience of these 11 devices for over 2 years. We've understood their protection functionality, how they integrate onto the system, and what we feel would be in a position now. We perhaps don't want to use this device in its entirety because of some mechanical nature, but the actual device themselves, in terms of working to BAU, we think we could reduce those restrictions for minimising people's ability to come into contact with it, and that can have huge advantages in terms of space and also operational efficiencies. So that's been a huge thing of having the policies and procedures and getting the feedback from the guys who are operating and ultimately own those technologies from a local management point of view. Some of the StatCom, so I think not being able to do things perfectly. We had significant noise from our transformers due to harmonics created, and I think, again, what we've been able to do from operational experience, understanding the operation and control, inspection of maintenance, when and where it happens, we've been able to transfer that learning that for devices connected to power electronics, we should be looking to feed that into having noise enclosures in one of our later projects, a flexible power link connected at 33 kV. That will be in a standard. So what we've done is taken the learning of a revised engineering specification for the StatCom and then employed that into our next project to make sure that we don't fall into the same trap. And I'm sort of conscious that sounds like common sense, but having a process and a methodology certainly enables us to employ that. And I've already spoken about the superconducting elements, so getting kept very cold. What we've found out is that we took the idea at the start that you'll see lots of liquid nitrogen tanks. Hospitals always have them because MRI scanners are kept cold using superconducting magnets and technology. So we took the approach of hospitals can do it, other things. We have lots of engineers, we have lots of specialties. We can do that. What we found is that's fine when you have people who are available 24 hours a day on a manned site. So we've learnt through how we've operated and controlled this device, or rather inspected and maintained it every 6 weeks to make sure it can stay online. That's probably not something that's appropriate in our world because we we don't like visiting site every 6 weeks for one specific piece of technology. So what we've looked to do is redesign how we can just have a large tank like a hospital does, where there's no cooling mechanism. If it slightly warms, we put new liquid nitrogen and we can top that up. And that's gone through and enabled us to maximise our, certainly the availability, and we're learning on the reliability. So just a few ideas that making sure that we capture all our processes and capture the inspection and maintenance, we can start understanding what has been good and what hasn't been so good. And we've made some decisions that we can see there from those examples that we were going to do for next time that we've been able to live with. And that last example of getting around the cooling mechanisms and putting a large store of liquid nitrogen has been an in-trial change that we felt like we had to implement, and that's come from the local teams having that engagement and more than a few people having to go to that site on a regular basis. So sort of in the sort of spirit of it being more of a dialogue, I'm hoping to sort of give a bit of a conclusion and then what aren't we doing at the moment and what could we possibly do. So I think it's obvious that, well, we can never design a perfect system at any time, but certainly not with innovation technologies and systems to be looking in place. So capturing why we'd made those decisions and documented those and being able to adapt them and have some history of what's happened to benefit the guys who ultimately have to use them has been massively important. So that's backed by developing the policies and procedures to make sure that that happens before the device is installed, so we can understand why decisions were made, reference those and update them. With all technology installations, we look to closely monitor that, understand what's going to happen and how we might want to make improvements next time or in trial changes and update our policy documents. So at the end of the project, we can hopefully go live with a BAU solution that's ready for people to take forwards. And latterly, that's what's happened on some of our fault current limiter installations. And we've given customer quotes using fault current limiters as the mitigating action to excessive fault levels rather than traditional solutions. So I think from the last 4 or 5 years of the innovation projects, we've made a huge step that 3 months after the end of a project, we've quoted a customer connection with what was innovation through to a business as usual solution. But that was sort of our approach and what we did in a sort of isolated innovation team and wider WPD. And I guess interested what other people have done and what else can be done to sort of smooth that transition and de-risk new assets coming onto the network.
Back on 20 minutes, John. Thanks. Okay, so in the breakout session, we'll be asking ourselves that question that John's just posed there. Before we move on to Teresa, are there any questions you want to ask of John on what he's presented?
I'll quickly disappear there.
John, I've got one.
Yeah, well done.
So in invigorating this process to address the innovation, did you find that perhaps you've gone a bit stale on existing legacy processes associated with the oil film kit and the legacy aspect as well?
I don't want to sort of shirk that question. Obviously, I was sort of looking at this, but I think what we looked to do in terms of sort of taking it as standard was sort of lean on what had happened. So I wouldn't be massively aware of all the traditional works, but obviously we've sort of taken the process of the regular reviewing and we found that's good enough for the innovation at the moment, fitting in with what's regular. So I'd take the view that innovation is probably what needs updating and reviewing the most, perhaps, or maybe that's a failure thinking about that, but I wouldn't have the exact answer. I was looking around to see if Paul Jewell was in the room, but I think he's decided to go next door and can perhaps answer that.